Welcome all to my channel. In this video class, we see about the next important drawing, that is hyperbola under the eccentricity method. Sometimes the name of the curve may not be given in the problem, only data would be available. In that case, referring to my previous video class 5 details, it may be decided depending upon the e value given like 1.5 etc. For example, see this problem and let me read the problem first. Draw a curve given that the distance of focus from the directrix as 40 mm and eccentricity is 1.5. Draw tangent and normal to the curve and name of the curve also to note. In this, the distance is not given, only ratio is given as 1.5. So, the finished drawing is shown. However, details of finding the V, etc. may be followed in the next step. Now, as per step 1, first draw the vertical directrix line and axis line. That is, vertical directrix line to approximate height and name it as A dash as shown. From the approximate center, draw a horizontal line perpendicular to the directrix to approximate length and give the name as B dash. This is the axis line. Next, as per step 2, the focus and vertex are to be marked on this B dash line. If it is given in the problem like 3/2 etc., the ratio may be used directly for marking. But if it is not given, then the V and F point locations are necessary to decide from any of the given data. That is why in this problem we have to follow the step 3 to find them. The third step is most important because in some of the cases, even though we know thoroughly to draw the hyperbola, but due to ratio like 1.5 given, instead of distance measurement, how much distance from B to V, or ratio like 3/2 etc., we may be not able to have an idea to locate the vertex V point, leading to dropping the problem only because of this simple step. That is why the third step is become essential to decide V and F points distance from V. But that should also be within the condition based upon the given problem data. Next, as per step 3, method of finding the focus and vertex. Here, to find the V, that is the main requirement, E is equal to 1.5. It is given in the problem. That is, E is greater than 1. Then it is hyperbola. We have already seen that. The ratio exceeds 1. In that case, it is hyperbola. We know VF by VB is equal to 1.5. It is given in the problem, that is VF by VB. By this time we do not know what is the distance between B and V, but we know from B to F, that is, it is given 40 millimeters. So that is equal to VF by VB equal to 1.5, that is VF equal to 1.5 into VB. Take it as equation 1. Also we know VF plus VB, VF plus VB, totally that is equal to 40 millimeter. That is given data in the problem. Take it as equation 2. Now using this equation 2 with the usage of equation 1, that is 1 is used in 2, then 1.5 VB plus VB equal to 40 millimeter. Therefore 1.5 plus 1, 2.5 VB equal to 40. Therefore VB equal to 40 by 2.5, that is equal to 16 millimeter. Now using this in the equation 1, that is VB we know now, that is 16 into 1.5. 1.5 into 16 equal to 24 millimeter. Therefore VF is 24 millimeter and VB equal to 16 millimeter. VF is 24 millimeter and VB equal to 16 millimeter. From B to F, that is from directrix to focus, that is given already 40 millimeter. Now we know the points. We can mark as shown here. It is 16 millimeter. We have to mark here. It is 24 millimeter. Totally 40 millimeter from B to F is to be marked now. Then we can proceed as usual. Now as per step 4, draw vertical perpendicular line at V. That is V is already located. Now draw a perpendicular and vertical line to the axis at point V as shown, so that mark C taking VF equal to 24 millimeter. It is already known, may be taken in the compass, and an arc may be drawn like this to find the point C, or otherwise we may also take divider this VF distance and make a mark on the vertical line. Both are correct. So now join the line BC and extend the line to the required length. This length will be used for marking the various points to decide the path of the hyperbola. Now as per step 6, draw the required parallel lines to VC, that is draw perpendicular lines above and below the axis, and also they are parallel to VC as well as directrix, as done for the previous problems to required number of lines. But remember once again, gap between successive lines are not compulsory to any value or equal value. That is, as required, they may be decided and drawn as shown at approximate uniform gaps based on the suitability. Now as per step 7, we have to mark the joining points, that is the meeting points of the all perpendicular lines which are drawn now and the axis line are to be marked and named as 1, 2, 3, 4, etc. Up to 6 or more than that if required may be named on the axis line. Similarly, all the meeting points of the perpendicular line on the BC line extension are to be marked and named as 1 dash, 2 dash, 3 dash, etc. and the same vertical lines below the axis at the same distance from axis line are to be marked as 1 double dash, 2 double dash, etc. But if it is required, it may be done, but it is not compulsory, since anyone, as explained earlier, either BC extension or BC dash extension is sufficient. So this is only a guidance line, just for showing the path guidance. Next, as per step 8, mark and name all the arc points. Here the hyperbola path points are to be marked first above and below the axis line. For this purpose, F is the first important point, because for all arcs F is to be taken as the center, whatever may be the distance. To mark the first arc as shown above and below axis and name them as J1 and K1. For this, take the 1 dash distance in the compass, keeping F as center. Mark the two arcs on 1 dash and 1 double dash lines above and below the axis as J1 and K1. Similarly, taking 2 dash as the distance, keeping F as the center, mark two arcs above the axis J2 and below the axis as K2. The name should be given such that the arcs are to be continuously marked as shown here. Then for 3 also same way. Next to 4, next to 5. For example, 5 and 5 dash distance is taken on the compass, and keeping F as center, from the F mark one arc above the axis line, that is name it as J5, and one arc below the axis line, name it as K5. Similarly 6, and also if required further. So likewise we have to mark all the points required for the hyperbola. Next, as per step 9, join all the arc points. Here starting from V, J1, J2, J3, J4, J5, J6. Likewise we have to make a smooth curve for joining all these points. Likewise, join below the axis from V to K1, K2, K3, K4, K5, K6. Likewise, it has to be joined below the axis, so that the smooth curve throughout the two sides of the axis is obtained as a hyperbola that is required as per the problem. Next, as per step 10, tangent and normal are to be drawn. Similar to last problem, first select a point P at any place on the curve, and then join the P with the F, which is already known. So after joining this, draw a perpendicular line from F to the directrix. Then from that line, join this P and extend, so that name it as R dash. That will be the required tangent to the hyperbola through the point P. Then draw a perpendicular line at point P to R dash. That will be the normal to the hyperbola as required. Then the given dimension BF 40 millimeter, tangent and normal as RR dash and SS dash as noted here should be noted separately. Then another one, the name of the curve has been asked, that should also be noted here, and also it may be shown here as hyperbola. Next, as per the next one, pencil grade. Regarding pencil grade, similar to other problems, HB pencil with the dark and thickness is required to draw the hyperbola curve as well as the tangent and normal. And as usual, directrix and axis line may be drawn with medium thick. All other supporting lines may be drawn with minor thick or thin lines with using 2H pencil. With this, drawing is over. Thank you. We will see the remaining in the next video class. Thank you once again.